So here we have the rational fraction 2x over x cubed minus 1. Our goal will be to resolve it into its partial fraction. Let us begin. So here, whenever we have given a rational fraction, so here we have 2x over x cubed minus 1, we need to have the factors of the denominator part here. So here the denominator is given as x cubed minus 1. So we'll need to factorize it. Now here what we can do, we can rewrite x cubed minus 1 as x cubed minus 1 cube. This is done so that we have difference of cube. So whenever we have difference of cube, that means a cube minus b cube, so they can be expanded as a minus b multiplied to a squared plus ab plus b squared. So in our case, we have x cubed minus 1 cube. So that means a corresponds to x and b corresponds to 1. So if we expand this, so this is going to be the product of x minus 1 multiplied to x squared plus x plus 1. So here x minus 1 and x squared plus x plus 1 are the factors of x cubed minus 1, such that we have 2x over x cubed minus 1 also represented as 2x divided by x minus 1 multiplied to x squared plus x plus 1. So what we'll do, we'll try to resolve this rational fraction into its constituent partial fraction. For this, what we'll do, let 2x divided by x minus 1 multiplied to x squared plus x plus 1. So let's say that this resolves into two partial fractions. The first partial fraction being a over x minus 1, because this is a linear factor. Plus, then we have the other partial fraction where the denominator is x squared plus x plus 1. Now, since this factor is a quadratic factor, so we'll have to consider bx plus c. Right. So now our goal will be to determine the value of a, b, and c. So let this be number 1. Fine. So what we'll do, we'll take equation number 1 and we're going to multiply both sides with x minus 1 times x squared plus x plus 1, such that we get 2x on the left hand side, and on the right hand side we have x squared plus x plus 1 multiplied to a plus x minus 1 times bx plus c. Okay, so let's do one thing. Let's expand and combine all the like terms on the right hand side. So here we are going to get x squared. This is going to be the highest power of x. So x squared is going to have a coefficient a plus b. Added to x, the coefficient of x is going to be a minus b plus c. Plus the constant term. So the constant term will be a minus c. Okay. Now, if we consider the left hand side, so here we only have one term, a single term which is containing x. We need two more terms that contains x squared and the constant term, but they are not present here. That's fine. What we can do, we can rewrite it as 0 times x squared, which tells us that the coefficient of x squared is 0. That's why we don't have any term containing x squared. Added to 2x, so that's already present here. But we also need a constant term. So here's the constant term. There is nothing present, so we'll simply add 0 to it. Now, immediately what we can do, we can equate both sides. So when we equate both sides, so let's label this as number 2. So on equating equation number 2. So if we equate number 2, so that's going to give us few equations. So a plus b, which is the coefficient of x squared on the right hand side, so this will be equals to coefficient of x squared on the left hand side. So that's simply 0. So we get the first equation, a plus b equals to 0. Then we get the next equation by comparing or equating the coefficient of x on both sides. We have a minus b plus c. This will be equals to 2 because the coefficient of x on the left hand side is 2. And then coming to the constant part, a minus c, so that's going to be equals to 0. So let's label these three equations as equation number 3, equation number 4, and equation number 5. Now we have three unknowns, a, b, and c, and we have three equations. So we can easily use these three equations to obtain the value of a, b, and c. I'm leaving that as an exercise for you to try out. What I'll do is state the values of a, b, and c. So a here comes out to be 2/3, b comes out to be negative 2/3, and the value of c comes out to be positive 2/3. Now that we have the values of a, b, and c, we'll substitute this back into equation number 1. So here we have 2x over. Now, instead of writing x minus 1 times x squared plus x plus 1, we can simply rewrite it as x cubed minus 1 because we have already found out the value of a, b, and c. So here a is 2 over 3 times x minus 1. Then we have b. So b is negative 2/3 of x. So here what we can do, we can take it as 3 times x squared plus x plus 1. So in the numerator we have 2x minus 2 times x minus 1. So this is going to be the required partial fraction. So we have successfully resolved 2x over x cubed minus 1 into two partial fractions. The first partial fraction being 2 over 3 times x minus 1, and the second partial fraction is negative 2 times x minus 1 divided by 3 times x squared plus x plus 1. Now this is the final answer. And if you want to cross check, what you can do, you can combine the two partial fractions, and this result should give back 2x over x cubed minus 1.